Good morning and welcome everyone for this course Physics 1, which is generally made for the undergraduate level B.Tech students. Myself Gopal Chakraborty, Assistant Professor, Department of Physics, Greater Kolkata College of Engineering and Management, Baruipur. You can meet me personally at office premises ground floor physics laboratory, or if any doubt or any problem you can also send me the mail at godphysics6@gmail.com or gopal.chakrabarty_gkcm@jsgroup.org. You can also visit my YouTube page given here. Lots of videos are already uploaded there regarding discussion of physics and other problems. I am the subject teacher for this course. For the course page, you can visit MAKAUTexam.net or MAKAUTwbac.in. You can also find out the corresponding syllabus is uploaded here. The title of the course is Physics 1. The subject code is BSPH101. It is under the Basic Science course. It has a credit 4 and 3 lecture per week and 1 tutorial per week. So this course is generally made for B.Tech degree students of first year. So CSE, civil and mechanical students, departmental students will going to study this course for this first semester or odd semester, and EC electrical departmental students is going to study the same course in the next semester, that means even semester. Today I am going to discuss about the vector differential operator, Gauss divergence theorem, Stokes theorem, vector differentiation and integration, which is under the second part of vector calculus, and under module 1 is mechanics. So the prerequisites are fundamentals of mathematical calculation and elementary idea of physics. The course objective is to present the fundamental concepts of vector calculus and to develop the students' understanding and skill in the topic necessary for its applications to science and engineering. The corresponding course outcomes are manipulate vector to perform geometrical calculation in 3-dimensional, compute vector differential operator, Gauss divergence theorem and Stokes theorem, and also calculate different type of vector derivatives, integration, etc. So, before going to study the vector differential operator, you have to know what is the meaning of the operator. Say, what is calculator? Calculator means which can calculate. What is regulator? Which can regulate. Similarly, what is operator? Operator is basically which can operate over some quantity and change the value of that quantity to another quantity. So operator is basically it's a function. So when you operate this operator over some scalar quantity, it will change only the magnitude. If you operate this operator over some vector quantity, then it will change both the magnitude and maybe the direction also, okay, according to the operation. Similarly, so operator means it's basically a function. Now I will going to tell you what is vector differential operator. So here is our vector differential operator. So many names it has: Dale operator, Nabla operator, gradient operator, divergence operator, Kerr operator, so many. So here this is the general form of vector differential operator. So it is a 3-dimensional operator having value del is equals to del del x I cap plus del del y j cap plus del del z k cap. So when this applied, this is a function, differentiation function. If you apply this operator, vector differential operator, over some quantity, that means it will certainly change the value of that quantity to another quantity. Okay, now as per the operation of vector differential operator, I will discuss why it is called gradient operator, why it is called divergence operator, and why it is called curl operator. Okay, so one by one. First one is gradient operator. So when this vector differential operator is operating over some scalar quantity, so your result will be a scalar 1. No, your result will be a vector 1, and then that operator will be called gradient operator. So it means the same operator, vector differential operator, when it operates over some scalar quantity, it makes it vector actually. So it changes the value of the scalar quantity, as well as in addition with the change it gives it some direction, so it makes it a vector quantity. So this is your gradient operator. It better to understand with a simple problem. Let us consider phi is a scalar quantity, that value is phi x square plus y square plus z square, as I have considered here. Now you apply the del vector differential operator over that scalar quantity phi. So you have to operate del x I cap plus del y j cap plus del z k cap over that phi quantity. So there is a derivative of del x over x square plus y square plus z square with I cap plus del y of x square plus y square plus z square j cap plus del z of x square plus y square plus z square k cap. So the result gives you, from the first one you will get only 2x I cap, from the second one you will get 2y j cap, and from the third one you will get 2z k cap. So your result is 2x I cap plus 2y j cap plus 2z k cap. But you have started with x square plus y square plus z square, that is your scalar quantity, scalar function. Now when you operate this vector differential operator over that phi quantity, it now makes it a vector quantity with a changed value. Okay, so now this operator will be called gradient operator. Now the second one, divergence operator. In vector calculus, divergence is a vector operator that operates on a vector field, producing a scalar field giving the quantity of the vector field source at each point. More technically, the divergence represents the volume density of the outward flux of a vector field from an infinitesimal volume around a given point. In three-dimensional Cartesian coordinate, the divergence of a continuously differentiable vector field is defined as the scalar valued function and is given as, for the simplicity, we have considered the vector A. The vector A is given by ax I cap plus ay j cap plus az k cap. So we take the dot product of vector A with the vector differential operator del. So del dot A will give you del x I cap plus del y j cap plus del z k cap, whole dot with ax I cap plus ay j cap plus az k cap. So it makes the result is a scalar quantity. So it is the del x plus del ay plus del az del z. So we have started with a vector quantity. Now we comes to a scalar one after operating with that divergence operator. Again, for better understanding, I have considered and phi. Now phi is a vector quantity. The value of phi is equals to x square I cap plus y square j cap plus z square k cap. Now if I operate the vector differential operator del with a dot product, which makes it a divergence operator, so del dot phi is equals to del x I cap plus del y j cap plus del z k cap dot with x square I cap plus y square j cap plus z square k cap. So now the dot product makes it a scalar 2x plus 2y plus 2z only. So here you can say, so the vector differential operator when operates over some vector quantity with dot product gives the result scalar one, so that operator will be called divergence operator. Now the last one, that is curl operator. In vector calculus, the curl is a vector operator that describes the infinitesimal rotation of a vector field in three-dimensional Euclidean place at every point in the field. The curl of the point is represented by a vector. The attributes of this vector, length and direction, both characterize the rotation at that point. The direction of the curl is the axis of rotation as determined by the right hand rule, and the magnitude of the curl is the magnitude of rotation. If the vector field represents the flow velocity of a moving fluid, then the curl is the circulation density of that fluid. A vector field whose curl is 0 is called irrotational. Now, if we consider vector A is equals to ax I cap plus ay j cap plus az k cap, the curl of vector A will give you, this vector can be calculated as, to take the determination of del cross A by putting the value ijk, del x, del y, del z, and ax, ay, az. You know what is the as per determination formula, you put the value and you will get the curl of vector A. In mathematics, the Laplacian operator is stated as the differential operator given by divergence of the gradient of a function on Euclidean space. It is usually denoted by the symbol del dot del, where del is the nabla operator. So, as the vector differential operator del, it is a vector quantity having value del x I cap, del y j cap, del z k cap. So, del dot del will give you a scalar quantity having value del square, that is equals to del 2 del x2 plus del 2 del y2 plus del 2 del y2. So, it is a second order partial differentiation derivative of x over y and over z. So, now if we apply this Laplacian operator over some scalar quantity, so it will change the value like this. I have considered an example. So, if I considered phi is a scalar quantity, that is x square plus y square plus z square, and now if I apply the Laplacian operator del square over phi, that gives you the 2 plus 2 plus 2, that means 6 only. So, this is the results of application of Laplacian operator over this scalar quantity. So, these are the different types of vector differential operator that you have to use to solve the problems from this vector calculus chapter. Now, to discuss about vector integration and vector differentiation, these are almost same as you have already done in your mathematics chapter in class 12 or in the mathematics for your vector first year. Now, the for integration here you have to take the line integral or surface integral or volume integral. So, three types of integration is there. So, line integration means, that means you have to take the integration over some line, so over some path. Okay, so the total value will be calculated after calculating the line integral. If you consider some infinitesimal value is given for an infinitesimal surface, and you are asked to calculate what will be the total value over the whole given surface, so you have to apply you have to calculate the surface integral. Or in case of for infinitesimal volume, some value is given and you are asked to calculate the total volume, then you have to take the volume integral. So line integral means that will be over either dx or dy or dz, any of the axes. If it is a surface integral, so you have to take the integration over dx dy or dy dz or dz dx. So surface means it's the area, so you have to take two-dimensional axis. And in case of volume integral, you have to take the integration over dx, dy and dz. So it's a three-dimensional space. So these are the integration that you have to done in case of vector calculus, but you need some relation between the surface integral with a volume integral or line integral with the surface integral, because using this relation you can convert a surface integral to a volume integral or a line integral to a surface integral. So now I am going to discuss this theorem. One is Gauss divergence theorem, another one is Stokes theorem, which gives you some relation between these three integration. So the first one, Gauss divergence theorem. In vector calculus, the divergence theorem, also known as Gauss divergence theorem, it's a result that relates the flux of a vector field through a closed curve to the divergence of the field in the volume enclosed. More precisely, the divergence theorem states that the surface integral of a vector field over a closed surface, which is called the flux through the surface, is equals to the volume integral of the divergence over the region inside the surface. So you can write closed surface integral A dot ds, that will be equals to closed volume integral del dot A dv. So that is our Gauss divergence theorem. Next one is the Stokes theorem. In vector calculus and more generally differential geometry, Stokes theorem is a statement about the integration of differential form on manifold, which both simplifies and generalizes several theorems from vector calculus. Stokes theorem says that a theorem proposing that the surface integral of the curl of a function over any surface bounded by a closed path is equals to the line integral of a particular vector function round that path. So here the mathematical expression is closed line integral A dot dr, that is equals to closed surface integral del cross A dot ds. So these are the two expressions corresponding to Gauss divergence theorem and Stokes theorem. So these are the important formulas from vector differential operator. First one is del, the value is given, already I have discussed. Second one is del square or grad square, that is also discussed. R is the positional vector and r square is x square plus y square plus z square. The fifth one is a new one, that del of r to the power n, that will give you n r to the power n minus 2 dot vector r. I will derive this formula also to know how it will come. 6, that is if del dot A equals to 0, that means if a divergence of a vector is 0, then that vector will be called solenoidal vector. And 7, it is del cross A equals to 0, that means if curl of some vector is equals to 0, then that vector will be called a e-rotational vector. And 8 and 9 will be your Gauss divergence theorem and Stokes theorem, which I have already discussed. So these are the important basic formula to solve the numericals from this vector part. Okay. Now I will solve some numericals, so you will understand how you will solve this problem. Here is your first problem, that calculate the unit vector which is normal to the surface phi. The equation is given phi equals to x square y plus xy square plus 3xyz at some point 1, 1 and minus 1. So how you will solve this kind of problem? First you have to take the gradient of this scalar function phi. So if you take the gradient of the scalar function phi, that will give you the vector which is perpendicular to that surface. So first of all I am calculate here the grad phi. So using the same formula that will give you here is I del del x plus j del del y plus k del del z over x square y plus xy square plus 3xyz, and your result is here, which makes it a vector quantity. Now we substitute the point that is given 1, 1 and minus 1. So x equals to 1, y equals to 1 and z equals to minus 1. So if you substitute these 3 points, which will give you del phi, grad phi value is only 3k cap. So this is the vector which is perpendicular to the given plane. Now you are asked to find out the unit perpendicular. So you have to find out the unit vector along the direction of 3k cap. So unit vector means that vector by mod of this vector. So here I have calculated 3k cap by under root 3 square, which will give you 3 cancel out. So k cap is our desired vector, desired unit vector, which is perpendicular to this plane. Now the next problem, that is, if the vector A and B are e-rotational, then you have to show the vector A cross B is solenoidal also. Okay. So the condition given is A cross B is e-rotational. That means curl of A equals to 0 and curl of B is equals to 0. That is already given. And you are asked to find out it is solenoidal. That means del dot A cross B will be equals to 0. That things you have to prove. So del dot A cross B equals to B dot del cross A minus A dot del cross B. So that means if you substitute the value of del cross A and del cross B equals to 0, so we got our result that del dot A cross B equals to 0. So divergence of A cross B equals to 0. That means it is a solenoidal. Next problem, show that vector field A is e-rotational and conservative. So to prove a vector to be a e-rotational and conservative, you have to show the curl of that vector is equals to 0. So here we have done curl of A. So it's simply that taking the determination of vector A, and that results 0. You can see here, you just simply put the determination formula and you will get the result is 0. So that means A is e-rotational and conservative field. Okay, next problem. If R is equals to mod of R, where R is xi cap plus yj cap plus jk cap, prove that del of 1 by R is equals to minus of R by R cube, and del R to the power n equals to n R to the power n minus 2 dot vector R. So first problem, here simply I have put the value of del over 1 by R. So if I calculate the partial derivative del del x over 1 by R, and the problem is that you can't take the derivative over like R over x. So we have changed that value, and if we change that value as del del R of 1 by R del del R del x I cap plus del del R 1 by R del y j cap plus del del R 1 by R del z k cap. So we get our results, that's equals to minus of 1 by R square x by R I cap minus of 1 by R square y by R j cap minus of 1 by R square z by R k cap. So simplifying we get minus of x I cap plus y j cap plus z k cap by R cube. So that means equals to minus of vector R by R cube. Okay. Now the next one, again the same thing. We have substituted the value of R to the del of R to the power n by del x by del R to the power n by del R into del R by del x of I cap plus del of R to the power n by del R into del R by del y j cap plus del R to the power n by del R of del R by del z k cap. So first term you can take a common, so that will give you the value n R to the power n minus 1, and the value which is within bracket, that will give you x by r I cap plus y by r j cap plus z by r k cap. So if you take 1 by r common, that will give you n r to the power n minus 2, and within bracket, that is x I cap plus y j cap plus z k cap. That means ultimately you will get n r to the power n minus 2 dot vector r. So we have achieved our result. So you can use this book as your reference book. Okay. It's also vector calculus books. Okay. You can solve lots of numerical from these books. Okay. And if you feel any doubt, you can send me your doubts in godphysics6@gmail.com in my mail ID. Okay. Or you can also personally contact me. The evaluation process is same. Internal exam for 30 marks and external exam for 70 marks, out of which internal examination will be conducted, that is for 15 marks, and assignment for 10 marks, and attendance for 5 marks. So hope all of you have understand the vector I have discussed here, were basically from different types of theorem and differential calculator, vector differential operator, and different calculus integration. So thank you. So with these two video lecture, I have completed the theory portion, theory part, and the formula of the vector chapter. So next day we will solve only different types of problem which completes our vector calculus chapter. Thank you.